Let's look at how Preddle can be used for machine learning or data mining. For those of you that are unfamiliar with these terms, this involves letting the computer sift through your data to automatically identify pockets of cases where the response variable is high or low or in between, i.e. automatically segmenting all the respondents in your study based on their level of gambling addiction. Because it is largely automated, you can get usable results in almost no time. Under the Data Mine drop-down, click Settings to set up some machine learning runs. There's some reference information down the bottom that will come in handy in a minute, so let's quickly scroll down. First of all, we've got a summary of the workspaces that are available in this dataset. Each workspace has different response and offset variables, if applicable. Although we didn't in this gambling problem example, if in the workspace wizard we went through in one of the early videos, we said that we were modeling a ratio, the numerator in the ratio would be the response, and the denominator would be the offset variable. If in your own work you are modeling a ratio, I recommend watching the videos in the business data series, where ratios of insurance data are modeled. For the most part, both series cover the same content but with different examples, so there's probably no need to watch every video of both series. We are primarily interested in the gambling problems lifetime workspace. Across all records in this workspace, the weighted sum of the gambling problem scores is 656.8, and the sum of the sample weight is 2,867. To remind you what these are, on a weighted basis, there are 2,867 cases in this dataset. Each case has a gambling score attached. Most of these gambling scores are 0, but some are 1, 2, 3, 4, etc. The sum of these gambling scores across the whole dataset, after allowing for weighting, is 656.854. Below that is a description of the algorithm the data mine uses. To use the lifetime gambling problem workspace as an example, the overall gambling problem score of 656 is divided by 2,867, which is 0.229. This means that on the scale of 1 to 10, the average gambling problem score across the whole dataset was 0.229. Now the vast majority of people of course scored 0, that's why it's so close to 0. But there will be some segments of the dataset that have a score much greater than this average, and other segments that have a score much smaller. What the algorithm does is to split the data into smaller and smaller segments based on the predictors that you specify, in order to identify what these really high and really low segments are. For example, it might split on respondents younger than 40 years versus older than 40 years. And then within the younger than 40 years, it splits it into male versus female. Then within males, less than 40 years, it splits it into college graduates versus non-college graduates, and so on. Each split is chosen intelligently by the model in an automatic way, such that the difference in the gambling problem score between the two subgroups that it creates is as wide as possible. It will keep splitting in this manner until it can't split anymore, while each segment meets minimum size conditions that we specify. There is also a penalty term in the algorithm to ensure that at each split the two subsegments are as equal in size as possible. We want the subsegments to be fairly equal in size, with the scores of each subsegment as different to each other as possible. This is how the algorithm identifies the pockets of respondents that are most at risk or least at risk of gambling problems. Now importantly, this splitting algorithm can not only be used to segment the ratio of interest in each workspace, but having fit a GLM model, we can use this algorithm to segment the residuals from the GLM model. Remember, residuals are the actual value minus the modeled value for each case or each record. If the GLM is systematically mispredicting particular segments, this data mine process should find it. Then you can go back into your GLM and make the appropriate adjustments. Let's let the algorithm use all the predictors that it can, like this, to make it interesting. We selected the variables to include by checking the boxes. We can create many different runs, each with slightly different settings, but we need to name each one. So, to be creative, let's call this one datamine run 1. As with the GLM modeling, we need to choose which workspace we're interested in. Select Gambling Problems Lifetime. We want to mine or model the response for now, rather than the residuals. If we did want to mine the residuals, we could select either the raw residuals, the Pearson residuals, or the deviance residuals, or we could even mine the model values themselves. Next, we choose the minimum observations per node. A node is a segment. The obs is the minimum sum in the denominator in the ratio. In this, it's effectively the minimum number of cases in each segment. There are 2,867 cases, so with a 1,000 minimum, we would expect around 2 segments, since each segment will have between 1,000 and 2,000 cases. Any segment with more than 2,000 cases could be further split into 2, so we want more than just 2 or so segments, so let's reduce the minimum to 200. Let's leave the penalty factor at 0.1. In the data mine process, we don't have the benefit of standard errors, confidence intervals, and significance tests to validate the model. In order to validate, Preddle splits the data into a training set to actually fit the model and define the segments, and a separate validation set to test the model against. The 70% of the data in the training set is used to come up with the model or come up with the segments. But that model may or may not generalize. The model or the segment definitions are tested against the 30% of data in the validation set to confirm that the model works well and that the segment definitions generalize. Preddle randomly splits the data for us in the proportions that we specify, in this case 70-30. We do recommend splitting 70% of the data into the training set and 30% into the validation set. But you can change that here if you prefer, but we won't. Let's run the data mine. When it finishes, we get automatically taken to the segment definitions page. You can also access this page at any time by selecting definitions from the data mine drop-down.